So that's what we call the matching, right? And let me give you some other concepts associated with this matching. Say an independent set M is called a maximum if M is not properly contained in another independent set. So an independent set M is called a maximum. So which means M cannot be, you cannot put into, you cannot enlarge M, right? So there's no way to put M as a proper subset. It's a proper subset, so which is strictly larger than M, right? So it's not impossible to put into another independent set which is strictly larger than M, right? So that's what we call the maximum. And if I look at this graph, if I'm going to call this is going to be my M1, and if I look at this M1 here, there's no way for me to add any more edge into this matching, right? Because if I add this edge, they are going to share one common vertices, right? If I'm going to add this edge, this edge, this edge, so in this way you see this is maximum. If you look at the second one, my example of number 2, M2, and if you look at this matching, B, G, F, B, G, F. Again, you will see this is the maximum. Okay, so as you can see, according to the definition of maximum, right? So which you are not able to add any more edge into this matching, into this independent set to still keep the property of the independence, right? So that's what we mean the maximum. Both of the two matching is maximum. So of course, if I just give you one edge, right? So you can easily see, there are some example which is not maximum. So that gives me a little bit of problem. I do see this M1 is maximum, and I do see M2 is maximum, right? So that propose another concept. I'm going to call that alpha of G. Sometimes usually people call it alpha prime of G. So that's this is called the edge independent number of G be the maximal cardinality numbers sets of edges. I'm going to introduce another constant, which I'm going to call the edge independent number, alpha prime. This is a maximal cardinality of all independent sets of edges. Or I should say this is all independent sets of edges. So look at all of the possible independent sets. all of the possible independent sets. So for example, this is a maximal one, one of the maximal one, and this is another maximal one. But if you look at the cardinality, right? So this is 2, this is 3. So I look at all of these cardinalities and find the largest one. The largest one is I'm going to call it's going to be alpha prime of G. Right? So this is at most, right? At most of the number of the edges you can find. You can still keep this as an independent set, right? So that's a maximal at most number of the edges you can find to still keep it. It's going to be an independent set. So there's two different concepts. One is here is a maximal matching. Say an independent set of edges is called a maximal matching if the cardinality of this independent set. So if this is an independent set M is a maximal matching if the cardinality of M is exactly equal to alpha prime G, right? So if alpha prime G is exactly equal to the cardinality of this independent set of edges, then I call this is a maximal matching, right? So there are two concepts. It's sometimes it's a little bit confusing, which is maximal matching, and the other one is a maximum matching. Maximal matching basically means it's not a proper content in any other independent set. Maximum matching basically is not only it is maximal, but also among all of the maximals, it has the largest cardinality. We have to. Can we stop? Yeah.